Alright, as promised, I was going to put the full solution to these so you can always have something more that you can look at. Just remember, when we're figuring out what it is, side angle side does not work. Side 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 does not work, at least not with law of sine. We'll figure them out later. Side angle side and side 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 don't work. Angle angle side is good. Angle side angle is good. Side side angle, we could have two possibilities, or we could have no possibilities, but also for sure we definitely could have just one as well. So always look out for it. First, here are the answers to all the triangles, just so you can have them and be able to look at them real quick. If you want to pause the video, check your answers, that's fine. Fast forward to the ones that give you trouble. Let's look at the red triangle first, triangle number 1. What we're going to do right from the beginning is we're going to say, what do we need to find out in the end? Angle B, angle C, and side B. That's what we need to find. To do it, we already know both pieces of A, so I'm going to set up as sine of big A, sine of 30, over 20 is going to equal, I also know side C here, so I'm going to go with angle C directly across from it, and sine of big C over little c, which is 16. I'm going to go 16 sine 30 is going to equal 20 sine of c when I cross multiply. From there, divide both sides by 20. 16 sine 30 over 20. I can't divide by a sign. I can't divide by a word. Sine of c is locked in just as it is. So all that's left is sine of c. When I do that, whatever that number comes out to be, I'm then going to take the inverse sine of that number. So I'm going to find that c is going to equal whatever the inverse sine is, inverse sine of both sides. And I'll end up getting that angle C is 23.6 degrees. So angle C, 23.6. From there, I can immediately find that angle B must just be whatever's left in the triangle. So I already have 30, I already have 23.6. So minus 23.6 and minus 30. So angle B here is going to be 126.4 degrees. 126.4 degrees. From there, find side B is the only thing left, so I need to use sine of big B, sine of 126.4 over, don't know what little b is yet, that's going to equal sine of 30 over 20. Just another combination like we had over here that we already used. So, b sine 30 equals 20 sine 126.4. We're going to divide then by sine of 30. So b equals 20 sine of 6.4 divided by sine of 30. And when I do that, I should get 32.2. 32.2. Now, this was a side angle problem. Side angle. So I need to look for a potential second triangle. To do that, the first angle that I found right here, this is the one that's going to give me issues. The calculator tells me 23.6. I need to be smarter than it. I need to say that the other possibility, which would be C prime, I'll call it, will be 180 minus that. 180 minus 23.6 degrees, which means the other possibility for angle C would be 156.4 degrees. So if it helps, draw what this second triangle, I'll draw it in blue here, would possibly look like. It's still 30, 16, and 20, but now right here we're looking at 156.4 degrees. The problem here is that 30 plus 156.4, that's already more than 180 degrees. It ends up being, what, 186.4 degrees. You cannot have a triangle that way. That's too many degrees, so this triangle does not exist. We're only going to have one possible answer, and that's what we were given right there. So that means you're now done with number 1 with only one triangle. All right? Let's move forward to number 2. Number 2, the blue triangle, we have a obtuse angle at 118 degrees. So even if it's one side angle, I would say immediately, because it's obtuse, that there's only one possible triangle here. However, it's not even side-side angle. This one is angle, angle, side, which also means guaranteed only one possible triangle. So, what do I need to find? I need to find angle Z, and I need to find sides Y and Z. I can find angle Z immediately. Angle Z, I'm going to find by doing just triangle sum theorem. 180 minus 118 minus 29. So that means the angle Z is 33 degrees. To find well, our big equation, really, we're just going to have two very easy proportions. To find Z, I'm going to have sine of 33 over little z is going to equal sine of 29 over 11. And that's from the x's. And the same way here, find y, sine of 118 degrees over y equals the same thing, sine of 29 over 11. So I'm going to solve each one of these individually. I'm going to end up getting that z will equal 11 times sine 33 over sine of 29. And that's going to reduce, simplify, calculate out to about 12.4. And same thing here. Cross multiply 11 sine 1118 equals y sine 29. That means y will equal 11 sine 118 over sine of 29. Remember, in both of these that I'm looking at, in this problem over here, the sine and 29, they must stay together. When I divide, that's why both came down. Same over here. Sine of 29 has to stay together. That's why that gets divided. In this case, I get y equals 20.0. So y is 20.0, z is 12.4. Right? Number 3. I should look at this green triangle and immediately say, let's look. I have side, side with an angle in between. That makes it side, angle, side. If I were to try to set up the law of sines here, so I would have sine of big D over 16. I would have sine of 95 degrees over little o, and I would have sine of big T over 32. I don't have any proportion here. I don't have anything that happens. So right now, we cannot solve this triangle using the law of sines. We will be able to later when we do law of cosines. So for now, just if you get a side angle side, just know we cannot solve it. We will be able to solve it again later on. But side angle side, and same if we did, side 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 later on, you won't be able to solve it quite yet. All right, Syracuse triangle, the orange triangle. We're going to look the same thing and set up. What do I know? Well, I know both angle y and side y, so that's where I'll start. Sine of 44 degrees over 3. And I also know side s of 23, so I can set that up with sine of big S. So remember, sine and big S, you're going to have to stay together in that. Cross multiply, 23 sine 44 is going to equal 3 sine of S. Divide both sides by 3. So 23 sine of 44 is going to divide by 3 will equal sine of S. When I simplify that, that means that I will have here that sine of S is equal to about 5.3 equals sine of S. And right there, you should know, well, sine of S cannot be, sine of any angle cannot be bigger than 1. So I should say, does not exist. This cannot possibly happen. If you do it, you'll get a domain error. If you try to do the inverse sine of both sides, so if I did sine inverse on both sides, that will come up with a domain error. That's fine. Domain errors aren't a bad thing. But just note it in the end, that means that this triangle does not exist as it is written. And again, this is a good thing that this could possibly happen, because again, we had a side-side angle to start with. Last one, number 5, the purple triangle, Kansas State. Another one of side-side angle. So we need to look, we might have 0, we might have 1, we might have 2. Start with what I know. I have sine of 30 over 10 for the big K and little k equals, I have little u, so I'll do sine big U over little u 16. Cross multiply, 16 sine 30 equals 10 sine u. That means that sine of u will equal 16 sine of 30 over 10. It means sine of u equals, where am I? Sine of u will equal some value, but I'm going to take the inverse sine here and get that u itself is equal to 53.1 degrees. So again, let me make sure I have these marked up here what I need to find. I need to find angle u, angle s, and little s. I just found that big U equals 53.1 degrees. I can then immediately find big S as a result because they just need to subtract and get to 180, or add them up all up to 180. So this should become 96.9 degrees. And then to find side S, I'll do sine of 96.9 over little s equals, let me make sure I get this right, equals whatever one you want to. I'm going to do from the original. Sine of 30 degrees over 10. So S will equal here, you should have 10 sine of 96.9 over sine of 30, which will equal in the end a side length of 19.9. 19.9. Now again, let's check. Do we have a second possible triangle? This is the first angle we found. That's the one I need to check. When I check it, I should see that my possible u prime would be 180 minus 53.1, which would equal 126.9 degrees. That would mean that s prime, if this was a real triangle, would be 180 minus u prime, so minus 126.9, minus my original angle of 30. And in this case, this is very possible. If it helps again, draw what the triangle would be. I would have 129, or I'm sorry, 126.9 here. 126.9. This only adds up to 156.9. So it's definitely possible to have a legitimate triangle for this. And when it does, the last angle, S, in this case would be 22.1 degrees. So that means second triangle would be angle U, angle S, side S. Angle U, 126.9, and angle S, to make it legal, it is legal, 22.1. To find the last side, I'm going to do the exact same thing that I did here, except now instead of the 96.9 degrees, I'm going to make S what it really is right now, which is 22.1. So sine of 22.1 degrees over S will equal sine of 30 over 10. And I'm sorry, I'm writing on a slant right now. Cross multiply, and you end up getting that S will equal, it should be 10 sine of 22.1 over sine of 30, which will equal in the end 2.5. So in this one, you do have two triangles as a result. There you go.